Hi everyone, welcome to AI Product Design. This is a course at Plaksha University where I'm an assistant professor. In this course, we talk about how to use AI tools to create software products, and we also talk about how to integrate AI into these software products. We go through the entire life cycle of being able to talk to the user right towards the end where you're testing your developed prototype with the user. We do not talk about scaling to millions of users in this particular course, but if that is of interest, maybe we will have another course on it. So let's dive right in and try to see what exactly has changed in the AI world recently that there is a lot of fuss about creating software. So, right from the beginning, our tools have always changed what is required of us. Right? When industrial machinery came out, the physical strength became less important. When weapons came out, warfare changed completely. When computers came out, the entire information processing, computation changed drastically. And when internet came out, aggregation of resources became more and more possible. Right? So our tools have always changed what is required of us as humans, and AI is not any different. AI will also change what is required of us as humans. But let's try to understand what exactly has changed in software. Right. So I really like the framing by Dr. Andre Karpathy. He gave this talk at YC AI Startup School, and he talked about these three paradigms of software. In software 1.0, essentially you wrote logic which was very well defined within the syntax of a particular language. For example, in this software 1.0 example, you can see that uh, to write a sentiment classifier, given an input sentence, if you have to say whether this is a positive sentiment or a negative sentiment, the person has chose to find some positive words, some negative words, and then based on how many words you could find of what type, you would label this as a positive or a negative word. Now you can imagine that this is not a great way to be able to classify the sentiment of a particular sentence, but this is probably pretty close to what you could do in a software 1.0 paradigm, right? Of course, you could do better in software 1.0 as well, not questioning that, but we will just talk about how the paradigm has changed from software 1.0. So in the software 2.0 world, what has changed is that now you could do 10,000 positive examples, 10,000 negative examples, right? And now you could learn a classifier which is actually able to learn automatically what should I look at in these words to be able to call this a positive sentiment or a negative sentiment. So using this paradigm, now you could use data without actually writing code to be able to find these attributes about the inputs examples, right? And this goes for a lot of things. You could now label images, you could now label graphs, you could now label whether this person is going to be a friend or not, right? For example, on Facebook. So this is the paradigm which was brought about by software 2.0, and it was largely successful. People also said data is the new oil. Well, not anymore. Welcome to software 3.0, right? So in software 3.0, you have these very capable large language models which have been trained on a lot of data, right? And because you've trained this on a lot of data, there is some sort of a general intelligence which is expected from the model. I'm not going to go into the AGI versus LLM debate, but we are talking more generally on how these, what we could expect from these models even going forward, right? So now you could just tell this model in plain English that you are a sentiment classifier, and for whatever input that I'm going to give you, you have to say whether this is a positive or a negative. But to be able to integrate this with software 1.0 frameworks, right, you will have to control the output to be in a particular format. And therefore, you have some examples and you have some control over what exactly does this LLM give you as an output, right? But now you can imagine that the software 3.0 is also going to be part of some software 1.0 and 2.0 mix. And we will see this with examples in the coming slides. So software is now not only automating computation, but it is now also multimodal. It can understand what it sees. It can also understand what it reads or hears. And it can now reason and use tools as well. So now it can search the web for you. It can use the browsers. It can test the APIs. It can also iterate on its own outputs. If it does not like what it generated in the first go, it can always go again at it, right? So these are the capabilities that modern software does have. And now you need to think about how to translate these capabilities into products. So let's take an example of what software 1, 2, 3 transition looks like for a particular use case. So let's take the example of software 1.0, where this is the ultrasound of a fetus, right? And we're trying to figure out what is the growth normal, or if there are any anomalies, and what should the person do about it. So in the software 1.0 paradigm, you basically connected your devices correctly, made sure that the image is coming into this interface, the patient details are getting loaded. Don't worry, these are fake patient details. I generated this again through Gemini. Uh, Now the person was manually entering what are these four attributes that have to be input to some sort of a model here, right? Which is predicting how good is your growth stage as compared to other fetuses in this particular position. And this kind of a situation, this allows you to be able to still get value out of the product, right? So this was very well tested code where each feature has been tested and developed by engineering and product teams. There are central databases which aggregate information from multiple places. You have to build the software only once. You can use it for thousands of feet scans, right? So this still provided a great value add to the entire user community. In the 2.2 paradigm, what happened was that this segmentation now started happening automatically. You trained a model which is now able to take this ultrasound image and is able to capture the segmentation of the fetus very accurately. And because you are able to now train this very narrow expertise model for image segmentation, you're reducing the effort of the person who had to enter these things manually, and these things can now be detected automatically. So the person does not have to enter anything. Now they can directly see the output of this on, uh, on the growth chart. In the 3.0 paradigm, now this thing is pushed even further. So in the 3.0 paradigm, it is not only able to understand where the fetus is, but it is also able to figure out what the anomaly might have been. It can surf the web and find out what are similar cases which have happened before, and it can still give you a way to interact with it. Right? So you can ask questions, you can ask more details about how this thing went. So let's look at this particular screen in a little more detail, right? So in this particular screen, you see all the three components. You will see a software 1.0, which is all these buttons, all these views, all these panels. But you also see software 2.0, which is this narrow expertise model. It is probably better to still use a narrow expertise model for a specialized field such as ultrasound imaging, right? It is much more likely to be accurate given that it has already been trained on fetus images. And finally, it can use this agentic type of an architecture where it is able to surf the web, it is able to understand what these inputs are, it can also find similar cases, it can answer the human questions, and so on. The software 3.0 is enabling a user experience which is much beyond what you could do on the software 1.0 stack. So, with the evolution of software, how do humans have to change, right? I'm just coming back to the same question which we started with. How do humans need to change in response to this modification in software? And let's think about this, a little closely. If the software is able to build itself, so a lot of 1.0, 2.0 code was also probably written by 3.0 assistants like Cursor or Cloud Code, etc. Now, your a lot of your job is also going to be understanding the user requirements correctly, building prototypes quickly, and trying to test them with the users, right? So let's see what the excitement is about. So what is happening in the jobs world is that leaner teams are also able to achieve more. There is infinite demand for software. You might know these two stalwarts in the AI world, right? And in the product world. And essentially, all of these people believe that there is a really infinite demand for software programs, right from the grocery store that you regularly go to the Google CEO. Everybody needs software, right? So what software you're going to create, and this also creates an opportunity for creating the software for people who are only accessible to you, right? The person in a rural community would probably not be accessible to the Microsoft CEO, and therefore they will not be able to build a product for that user community, but you can, because you're in that community, right? So leaner teams are able to achieve more. What this also means is that humans will have to do more functions per person. You not only have to do coding now, you also have to do product management. You have to think about what to build. You have to think about doing sales. You have to understand how to gather user requirements and also test how your product is performing for a user. You have to understand what they would really want as an addition to your product. You also probably have to do human resource, which is to be able to find the right people for the right job within that small team who can do multiple functions per person, right? So this is an all-in-one function which is now becoming even more relevant. So the jack of all trades is probably the master of everything now. It also requires broader world models per person. It is now not enough to be just a great JavaScript developer, right? Because the AI is going to beat you to it. In very specialized tasks, like even math and coding, these specialized models are going to be able to beat humans pretty soon. So what is going to be even more required is that you think more broadly. You have a much larger world model and you understand a lot more about how things work than a specialized coder, right? And by the way, this used to be quite good not very long ago. So this is really a recent transition in terms of how the jobs are going to change. And most importantly, this requires more agency, right? I'm no expert at this, but I think ChatGPT did it very well. So I took this from ChatGPT. You have to be able to see constraints as negotiable, right? So rules, norms, job descriptions, these are all default settings and not hard limits. And therefore, we should think of them like that, right? You have to assume personal responsibility. When you're creating a product, you have to really think about, if the users are making this particular mistake again and again, what can I do about it to be able to fix this? You have to initiate action without permission. They don't need to be told, validated, or selected. You can reach out to more users, reach out to different types of user groups when you're trying to test your product, right? You have to design paths instead of following scripts. If the path does not exist, then create one. You have to be able to persist through ambiguity now more than ever. Even if you hear different things every time you're going to the users, you have to really put it down on how do you navigate through this ambiguity and still create a product that adds value to a lot of your users. And finally, convert your ideas into reality. It is not enough to be able to design a good product spec anymore, right? This is just a thought. Now you have to convert that to a prototype and then see what kind of an outcomes are you able to drive through it. So this is really what we are going towards. We're going towards more high agency humans, right? They already had an edge, but now we will all need to push ourselves towards that criteria. So in this course, these are the components. We want to talk about what do your users need, what should we build, what is the prototype that you can create, but can also people use a prototype? Can you test whether people are able to use a prototype? And finally, take the feedback from these interactions, re-prototype, and launch an MVP and evolve it. Right? So this is what we're trying to do in this particular course. I also found that there is this nice book which is based on the same principle. So please do give it a read if you like. Right. So in this particular course, at least within the university, we also connected our students with real users, right? So all of our executive teams actually pitched in, our HR, our faculty, student life community, right? All of these people have pitched in and gave us requirements for an AI product. And now students are actually working with these teams to be able to create the AI future for the university as well as for the world. So really, this is how we are, doing this course in-house. And this also, we are also forcing you to do things in an AI native way. The course is a 2 credit course. It only requires 15 hours of lectures and about 30 hours of labs. But that means that you have to develop an entire MVP into these hours, which means that you cannot do things the old-fashioned way. You have to be able to use AI to generate your code. You can't write your code manually, right? And this introduces you to possible tools for AI native workflows. So this course, even philosophically, is different from other courses, right? Typically, when you are trying to, let's say, study machine learning, people will suggest that you first study probability and statistics, learn some algorithms, and then finally come towards machine learning, right? But this is a top-down learning experience. So here we are trying to figure out, okay, this is the system that I need to build. So what are the things that I need to study? Do I need to study programming? Maybe, right? Data structures, databases, machine learning. What are the things that I need to be able to do so that I can build this product, right? And this particular course we offer to both second and third year students. So it's also an interesting experiment in some sense. Try and figure out, does teaching all of the courses in a bottom up fashion also make a difference for the third year courses, for the third year students, versus somebody who's still in the second year has only learned programming and they can still grasp a lot of concepts. So the course philosophy is really that I'm really not teaching in this particular course. This is a self-learning experience, but I'm facilitating learning through the assignments that we're giving, right? So we are designing the experiments such that you are able to get a maximum benefit out of it. This is a menu card approach. You have to know your options, but you can explore more when required. You have to understand how your tools work and what might work in what situation. But right, try to understand the basic principles around it. And you're not just learning how to use a particular AI coding IDE or a new AI tool. What you're trying to learn in this particular course is how to offer your user a very AI native experience, right? How do you build the cursor for your user? This is what we're trying to go towards. And by the way, Cursor is an IDE. If you don't know about it, please check it out on YouTube. Right? This is not the mouse cursor. So these are some topics that we cover in the course. We talk about how to talk to users, uh, what is web, what are the tools of the trade, right? How do you prompt, how do you design databases, how do you design RAG pipelines, agents. But we cover all of these very briefly so that you get more experience by just implementing this stuff. And finally, we evaluate students on these three criteria. There is a midsem presentation, NSEM, and a code review component. But I would really recommend, even if you're going to do the course on your own, just try to evaluate yourself on these three areas, right? Are you building the right thing? Have you made any progress? Have you collected any user feedback? Is your product usable? When you give it to the user, are they actually able to use it? Try to evolve your solution if not so, right? And do you understand what is going on architecturally on your code base? You have to be able to understand what framework are you using, what is the system architecture, what are the constraints of this particular system architecture, will you be able to deploy it or not, and so on, right? So I'm really excited about what you're going to build. Please do share if you have any feedback for the course in the comment section, right? And we're really looking forward to working with you towards making AI product design a reality for everybody. Thank you.